The third advantage to nonlinear access is non-destructive editing, and this is critical for almost every digital audio workstation that you'll find. Once again, it's time for our favorite pictures. So, non-destructive edits. There are some type of edits that don't take any extra space because it uses the same data. For example, if I move these pictures around and scale them, all that changes is the numbers in the reference that stand for the pictures that represents the display size or the position or what have you. It doesn't alter the original picture. That's quite different from linear systems that would have to do calculations on the data and then store it in memory, store a new copy of it. Instead, it's doing it on the fly. Eventually, I hope to get to an example of how digital audio workstations do this because nearly all of them use this same thing whenever you do audio editing. Let's briefly review the types of storage that we talked about last time. Memory and storage are the two terms that refer to these places where data could be, memory being short-term, storage being long-term, and we had this graph where there's a general trend of faster things being very temporary and slower things being more permanent, with a couple exceptions. You can look at the previous video to see more about this. But we're now going to apply this knowledge to how sounds can be edited in hardware. So we'll go through some terms and some paradigms for how things like synthesizers, guitar amp simulators, delay pedals, vocal effects, all sorts of things that let you store sounds in them, how those things work. So the terms that you'll find that you may be already familiar with are the patch, which is just a sound or setting. And the origin of this term comes from original hardware synths like the Moog, where you actually had to use cables and patch one place to another to make a different sound. After that came synthesizers that used buttons and knobs to set the sounds rather than patch cables, and so when you save a patch in a modern digital device, it's like writing down every setting of every knob, real or virtual, in the device. Then when you come back and load the patch, it's like adjusting all the knobs in the device to the settings that you wrote down when you saved it. So a patch is the collection of settings. You'll also often encounter the term bank, which is just like a folder of patches. Patches are usually numbered, so if patch number 3 in the first bank is a piano sound, maybe if you switch to the second bank and then call up that bank's patch 3, then it'll be maybe an organ sound or clarinet or what have you. The bank is like a way of getting around a limited number of patch numbers. The next concept that's important to know about these hardware devices is that almost every one of them has something called an edit buffer. They don't always use this term, but the concept applies to nearly every device that lets you store settings. The edit buffer is temporary storage, almost always in RAM, that stores the settings currently in use, the patch you're using at the moment. You can edit this, and that is what you are editing if you move real or virtual knobs on the machine. But if you call up a new patch, this edit buffer, this temporary storage space, gets overwritten. Usually it's power dependent, especially on older devices. Sometimes devices that are newer will save their edit buffers even when the power gets lost. But the thing to keep in mind is that overall, this is a volatile, temporary storage place that just stores the immediate settings that you're using right now. Most devices also have user and preset banks. Especially on older devices, you'll find that the preset banks are stored in ROM. Now here I should point out that the term preset is also sometimes used to mean patch. The critical important difference, though, is that a preset is a pre-programmed patch that's already in the device when it comes from the factory. On many but not all devices, the built-in presets, the patches that are programmed at the factory, are unchangeable. On some of them, you can change them. Even on the devices where you can overwrite the preset patches, usually they're stored somewhere in a hidden area so that if you do a factory reset, it will erase your personally edited patches with the factory ones. All these devices nearly always have user banks. Those are areas where you can store your own patches. The user area is always erasable, and it's semi-permanent in that it'll save it because it'll survive a power off, but you can always change it if you want to. And of course, there are some exceptions to all of these. As technology changes and different hardware for storing information comes out, manufacturers have begun using something similar to an SSD or flash memory for all of this so that it all becomes invulnerable to power outages. So in a typical device, You've got your user storage area, you've got the edit buffer, and you've got built-in factory presets. When you turn on the device, after first bringing it home from the store or wherever you get it, it will power up and then take one of the built-in presets and load it from ROM into the edit buffer. Or, let's say if you bought it used and it has some sounds that someone else programmed in, you might load the sound from the user storage area. Either way, you arrive with some kind of sound that you're playing on this synthesizer or guitar effect or whatever, and let's say you tweak some settings. Now you have edited the settings that are stored in the temporary edit buffer. If at this point you load something else, you will lose your edited settings. But if you want to save this now as a new patch, then you can hit some buttons, depending on what kind of device it is, they'll be different, and save that sound into the user storage area. And the circle continues as you continue to use the device. Now with most of these things, it's handy to have backups of your patches so that if the device gives out, you can just buy an identical one and reload your same exact sounds into the new one. But the question is, how do you get these settings outside of the hardware unit? Also, what if you have several different bands that you're playing in and you have a guitar effect pedal and you need to store more than the pedal can hold? The way you can do this is to connect it to a computer and transfer the numbers that represent those settings and save that as a file in your computer. The file you save would contain all the numbers that represent the setting of every single knob in the device, so that then, usually using software that comes with the device, you can manage all of that stuff between the computer and the device, and that solves both of those problems. Thanks a lot for watching. I'll try to include some specific examples of these things using actual synthesizers and guitar pedals so that you can tell what I'm talking about better. Thanks again, and I'll see you next time.